So now that we have our rest fields working nicely, if I middle mouse, we have rest 1 and rest 2, as well as the combined rest position. However, at this point, we don't need rest 1 and rest 2. That's just extra data that's unnecessary. So what a lot of people don't realize is that you can just delete rest 1 and rest 2 once you make your combined rest position. And you don't have to cache out a bunch of stuff for rest fields. And that's a big complaint for rest fields that people have, is that, well, okay, that's a lot of data that you're carrying along, but if you just go through this volume VOP, you figure out the combined field right here, you don't need rest 1 and rest 2 anymore. So that's just kind of mind-blowing if you've been working with this for a while. We just need this one position. And so anyway, how do we add noise? We can have a fog noise right here, this volume noise fog. From my understanding, this does not allow you to change the manifold, however. So I like doing it the old-fashioned way with VOPs. So a volume VOP right there. And what we'll do is we have density, right? We want to bring in that position. We just need to say bind and bring in our combined rest position. So combined rest pos vector. And then we can use any noise we want. So in this case, an anti-alias noise works just fine. There's our position. And we can take that noise, multiply that against density, and get, whatever typical noise we're used to. So I'll go ahead and pause the video. Adjusting noises should be something you guys know how to do. And I'll show you the result. All right, so now we have a fit, which again, for anti-alias noise needs to happen between -0.5 and +0.5. That goes to 0 to 1, feeds into a ramp, we multiply, and with the noise ramp like this, we can easily see what's going on. This is before, this is after. So we're really trying to cut into those values. And it also helps to have a ramp that's really high in contrast like this, that you can see it easily. So once we have that, and maybe I'll change the frequency to something around here, it's fine. Let's go ahead and do a play blast and be sure that the noise is seamlessly moving with the smoke and that there's no popping happening. All right, and this looks pretty good. We have it moving through. I'm not seeing any popping. It looks like the noise is moving with the cloud. And that's exactly what we want. It's a seamless illusion for the most part. Okay, well, here's another question. We have a very high res simulation. We don't want to store out a ton of information with this rest field. Does this still work if we resample the position to a lower resolution? So if we do a VDB resample, and let's say before this goes in, we try to resample our combined rest position to a explicit voxel size. So let's say that we start here at, it looks like 0.05. And what happens when we go to a voxel size of 0.15? So now we only have 12,000 voxels. That's a very coarse resolution. If we look at the colors of all that, we should see that everything is blurred out. So we still have the rest position, it's still there, but it's just really sort of blurred out. And it does kind of glitch out a little bit. However, what happens when we run that through the noise? Does it still hold up? And for the most part, this does fairly well. It does look a tad bit glitchy around here. So, watch right around there when it's moving up. You can kind of see it glitching out a slight bit. However, I'm going really aggressive with this. So if we had a really small resolution and you did this, I don't think it'd be that noticeable in most situations. So if you're worried about the cache sizes because you're saving out the rest field, then try downsampling a little bit. This is way too aggressive at 18,000, but you can get away with some of that. And especially if you figure this out ahead of time, You only need to cache out one field that's low res. It's not so bad. In the next video, let's move on to establishing rest fields within DOPS.